Hi students, welcome to AIMS India live sessions. As all the students are being at home, not able to come to school because of this COVID-19. So to help these students, we have started these live sessions to give you some fundamentals and basics presently. Now we are going to see chemistry subject. From chemistry, different states of matter. Matter and different states of matter we are going to discuss in this session. First of all, what is this matter and what is the nature of this matter? As you know, matter is anything that has mass and occupies some space and can be perceived by our senses. That is called as matter. For example, we can see here some examples for the matter are given here. You can see a glass of water, some ice cubes, a flask, ice fruit, some stones, the magma, lava coming out from the mountains, some metals like gold and dissolve, and even air, plants, these all come under matter. Because as we set the definition for matter, matter is anything that has mass and occupies some space and can be perceived by our senses. Our senses is like we can some matter can be touched, some can be seen, some can be felt. So in this way, that can be perceived by our senses. So, which is having these three properties that can be considered as a matter. So, these all come under different forms of matter. As we look around in our surroundings, we see a large variety of things with the different shapes, sizes, and textures. See, some examples are given here. Milk, it is in a glass, which is not having any shape here, and cool drinks, some metallic bells, air present in the balloons, some fruits, books, parachutes, pens. These all are different forms of matter. Why do we say these all are matter? Because these all are having those three properties what we said that earlier. That is, they have certain mass to them and they are occupying certain place or volume, and they can be perceived by our senses. We can taste the milk, we can touch the bottle, we can feel the air, we can see the colors of different books and pens, these all. So, in this way, that can be perceived, and hence these all come under different forms of matter. Everything in this universe is made up of materials which scientists have named as matter. So, to say clearly, everything in the universe is, it might be one of these two. One is matter, the second one is energy. So, in this chemistry session, we are going to discuss about matter. In chemistry subjects or chemistry topics, we are going to discuss about completely about the matter and its forms and the composition of matter, the elements, molecules, and their reactions. These all we study in chemistry subject. And the second one in the universe is energy. About the energy and different forms of energy, we are going to discuss in physics. Different forms of energy in the sense like light, heat, sound, electricity, magnetism. These all are come under different forms of energy. About these all, we study in the subject physics. Now here in chemistry, we are discussing about matter and its composition. Here in this session, we are discussing about different states of matter or different physical states of matter. The air we breathe, the food we eat, stones, clouds, stars, plants and animals, even a small drop of water or a particle of sand, each thing is a matter. Everything in this universe is a matter, but it should have those three properties mainly. Then it is considered as a matter. Here some are shown here. The air we are breathing and the food we are eating, plants and animals, these all come under matter and a composite of some particles. How can we classify these matter? As we said, water, air, animals, plants, even human beings, stones, sand, even a small particle of clay, these all come under matter we said. But how can we classify these all kinds of matter? Let us see here. As there are so many kinds of matter, a scientific study of matter becomes easier if we classify matter based upon the certain characteristics. So based upon so these factors, matter can be classified into two based on two factors. They are one it is physical classification and the second one is chemical classification. Based on these two factors, matter can be classified into different categories. Let us see this complete flow chart for this classification. Here it is given the classification of matter. In this, the first one is physical classification of matter. Based on physical classification in the sense based upon the arrangement of particles present in the matter. So, based upon this arrangement of particles, matter is classified into five types here. We can see clearly those five types are solids, liquids, gases, plasma, and Bose-Einstein condensate it is called. So, these are physical forms of matter. There is one more type of categorization of matter that is based upon the chemical classification. Means based upon the chemical properties of matter or based upon the chemical composition of matter, based upon the particles present in the kind of particles present in the matter can be classified again into different kinds. They are shown here: pure substances and impure substances or mixtures. About these chemical classification and types of substances, we are going to discuss in the next session. In this now, let us see the physical classification of matter. That is the classification of matter based upon the arrangement of molecules in it. So based upon that, it is classified into five types. Let us say about these five types of matter one by one here. So as I said, matter is composed of extremely small particles. Based on the arrangement of these particles, matter is mainly divided into three types. Of course, as we have shown in the chart, there are five types of matter, but frequently and very usually we see the main three types of matter. They are solids, liquids, and gases. Here we can see one example is given, that is which we see very frequently in our daily life. One it is solid form, that is ice it is given, and liquid form water, and a gaseous form of water that we say as water vapor. So about these three states let us discuss first. But before that, let us come back to this point once. Matter is composed of extremely small particles which we commonly say molecules. For example, if you take a piece of chalk, if you break it into small pieces, it becomes two pieces. If you continue breaking that like that, at certain time, we are going to get the very smallest piece of chalk, which you cannot cut with your physical means. The smallest particle of a matter, which we cannot break and broke into smaller pieces further, is called its a molecule. Based upon the arrangement of these molecules, matter can be mainly divided into three types. Those three are here shown: solids, liquids, and gases. So first let us say about solids. In solids, molecules are very closely packed. Their positions are almost fixed. Means, as we said, all the matters are made up of molecules. But based upon the arrangement of molecules, these states are being occurred. In solid states, all the molecules are very tightly binded. But we can say simply to understand, the friendship between the molecules is very high in case of solids. All the molecules will be always together. That for that purpose they will be rigid. They have their positions always almost fixed. So here are some examples for the solids. We can see here a candle wax and some ore or stone. We can say ice cubes, some fruits, and some bottle it is given. Some useful tools are shown here. These all come under solids. In these all, molecules are very tightly binded one to other. So these solids are having certain chemical property of certain general properties. Based upon these properties, these are categorized as the solids. So what are the general properties of solids? Let us see here. First among them is solids have fixed shape and fixed volume. For example, if you say an apple, it has a fixed shape. It won't change its shape until and unless we apply some force on that. And even these all the remaining solids also, they have fixed shape for them. And even they have fixed volume also. Always that way, they fixed volume. So solids they have fixed shape as well as fixed volume. Next property, generally solids cannot be compressed. Compressing the sense decreasing their volume by applying pressure on them. If you take any metal piece, if you take iron rod or iron piece, if you try to press it, try to reduce its volume by applying pressure on it, can we? No, we cannot, because they are highly rigid. Because in between the molecules of solids, there are no gaps. They are already tightly binded one to other. So the compression of these solids is somewhat difficult. That is, they are almost uncompressible. We cannot compress them. We cannot reduce the volumes of these solids. We may get some certain doubt here. We say generally sponge is a solid, but it can be compressed easily. Why? This is because even though this sponge is a solid, in the sponge also between the molecules there will be no gap. There also molecules are tightly binded. But its arrangement physically, there are air gaps in the sponge if you observe clearly. So when you press the sponge, the air present in the sponge will go out into the gaps created, these molecules of sponge will go. Because of that, we can compress a sponge, but it does not mean as it is not a solid. It is a solid. That compression is because of the air present in the sponge. So, okay, next point or next property of solids is a solid does not flow. Yes, solids cannot flow themselves until and unless you apply certain force on them, or if you apply certain pressure on them, they won't move from their position. They'll be always at a certain fixed place. That means they cannot move in their own. That means they are fixed at one place or they cannot slide. Next property, a solid expands very little on being heated. Not only expansion, even contraction also is very less for solids. If you take an iron rod or iron piece or any other metals substance, if you heat it strongly, a little expansion we can identify, but it is not much. Even the contraction also, when you cool these solids to very cool, low temperatures, they contract very less. That means the expansions and contractions are very less for solids. Next property. Solids have very less interparticular space and very high interparticular attraction. Here 2 points are there. Let us see them clearly. Interparticle space. This means, as we said at the starting, every matter is made up of small particles called molecules. These molecules are tightly arranged in solids. That means there are no gaps between the molecules. So here interparticular spaces means the distance between the adjacent molecules is called interparticle or intermolecular space. As in the solids, these molecules are, as they're being very close to each other, the distance between them is very less. So interparticular spaces are thus very less in case of solids. Whereas interparticular attraction, in between the molecules of matter, there exist some attractions that we call as intermolecular forces of attractions. Because of these attractions only, these molecules will be always held together. In case of solids especially, these attractions are very much high. I said already, the friendship between the molecules of solids are very high. So because of this, they'll be always together. They're tightly binded. So we can say the interparticular attraction or intermolecular forces of attractions are very high in solids. So next let us say about the next stage of matter, that is liquids. In liquids, the molecules are not packed as closely as solids. Of course, in liquids also, molecules are close or attracted one to other. But this is not that much extent as when compared to solids. So the attractions are somewhat less. So molecules are not much tightly packed in the case of liquids. Here we can see some examples they have given. The water we drink is a liquid, and some fruit juices and oils, soft drinks. These all come under blood, milk. These all come under different forms of liquids. In these all, molecules are not much tightly packed when compared to solids. The attractions are somewhat less in case of liquids. So now let us see the general properties of these liquids. So what are the properties of matter to be categorized as liquids? Let us see those one by one. First among them is a liquid has no fixed shape. It takes the shape of its container. Means in case of solids, they have a fixed shape and even a fixed volume for them. But by coming to liquids, they don't have any fixed shape for them. Of course, they have fixed volume. If you take 1 liter of water, if you pour in a mug, that will be 1 liter only. If you take the same water into a beaker, then also the volume will be 1 liter only. So liquids have fixed volume, but the shape is not fixed for them. They take the shape of container in which they are kept. If you take the water in a glass, they take the shape of the glass. If you pour the same water into a test tube, they take the shape of test tube. If you pour again the same water into a beaker, they take the shape of that beaker. In this way, not only water, all the liquids in the same way, they do not have any fixed shape. They take the shape of the container in which they are kept. So next property, a liquid can be compressed only to a small extent. As we said already, solids cannot be compressed, or the compressibility in case of solids is very less. But by coming to liquids, they can be compressed a little, greater when compared to solids, but it is not much. They can be compressed to a little extent. If you take certain water into a container, if you apply high pressure on that from the surface, they can be compressed a little, but not much extent. So next property, liquids can flow. It is one of the interesting point for the liquids, which is different from solids, which is not there for the solids. Liquids can flow. Why? Because we said here liquids, not only liquids, all the matter is made up of molecules. In case of liquids, molecules are a little loosely packed. Because of this loosely packedness, molecules in solids, they can slide one another. Because of this sliding nature, the liquids can flow from one place to other place. That too, from higher altitudes to lower altitudes. We know when you pour water, immediately it spreads on the surface. This is because in water, the molecules are loosely packed, so they can slide one another easily. They spread immediately on the surface available to them. So this moving from one place to other place is called flowing. So liquids are the substances which can flow. Next property, a liquid expands or contracts more than a solid. Yes, as we said, solids expands or contracts a very little to extent on heating or cooling. But this is a little greater in case of liquids. On heating, they expand a little greater in volume than the solids, and they contract a little greater in case of contraction also when compared to solids. Next property, liquids have more interparticular spaces and less interparticular attractions when compared to solids. We said already the interparticular spaces, that means the distance or the space existing between the two adjacent particles in a matter is called interparticular space. Chemically, it is said to be intermolecular spaces in the matter. In the liquids, molecules are loosely packed or particles are loosely packed, we said. So hence, the distance is a little greater when compared to that of solids. By coming to attractions, as they are loosely packed, the attractions between the molecules are somewhat less when compared to liquids. So interparticle attractions are less in liquids when compared to solids. So spaces are greater, attractions are less by comparing with solids in case of liquids. Next, the third state of matter, you can say they are gases. In gases, the molecules are at a greater distance from one another as compared to solids and liquids. So, as we said, in solids and liquids, molecules are bound one to other. In solids, the bindness is very tight. In liquid, they are loosely packed. But in case of gases, there is no binding. There is no friendship at all. One molecule will be here, one more molecule will be somewhere else, one more will be somewhere else. In this way, there are no attractions between the molecules of gases. That is very negligible in case of gases to say when compared to solids and liquids. So molecular distances are very much high. There are no restrictions for these molecules and the gases to move there and here. They can move freely there and here always. So here we can see they have given nice balloons which are containing air or gas in them, because we cannot give example for the air or gas which are colorless, which we cannot see the naked eye. So we can feel that in the balloon, we can feel when it is blown. So these gases can be felt, cannot be seen. Why? Because gases do not have any color, but it is not exactly. Most of the gases do not have color. That is why we are not able to see almost all the gases. Do you know one interesting point here? If what happens if gases have color? We know we breathe oxygen gas, we exhale carbon dioxide gas. If these two gases are having certain color, what happens then? What happens then? Then, we cannot see whatever it is there in front of us. This is because the entire air in this universe, in this air, empty places, it is occupied by air, as we know. This air contains different gases like carbon dioxide or oxygen, nitrogen. These all gases are there. If these gases are having certain color, immediately this completely will become dark to us. We cannot see anything in front of whatever it is there. As these gases are having no color, we are able to see clearly whatever is in front of you. So that's why I said we can feel the gases, but we cannot see them. But here one more question: are all the gases having no color? Or all the gases are colorless? No. There are certain gases which have color to them. For example, there is one gas called nitrogen dioxide, which is existing in reddish brown color. One more gas is there, chlorine gas, which is a greenish yellow colored gas. So, like this, very few gases are there which are having color to them. But of course, we know these gases they are not existing naturally. They will be prepared in the laboratory from chemicals. But in the naturally existing gases, they do not have any color. So, these of these gases. A gas has neither a fixed volume nor a fixed shape. It assumes the volume and shape of the container. So we can compare this property to solids and liquids. In solids, what we said, solids have fixed shape and fixed volume also. But by coming to liquids, we said they have fixed volume but no fixed shape. But by coming to gases, they do not have fixed volume as well as fixed shape also. And the volume and the shape of the gas is considered as the volume and shape of the container in which it is kept. Suppose if we take a certain quantity of gas into a bottle, the volume of the gas is considered as the volume of the bottle, and even shape of the gas also is considered as the shape of that bottle. So it has no fixed shape or fixed volume. Gases can be compressed to a much extent than solids and liquids. Yes, solids cannot be compressed and liquids can be compressed to a little extent, and gases, they can be compressed highly. For this, very fine example or very well known example for us, we can say that is the gas kept in the cylinder and which is used in our homes for domestic cooking purposes. We say LP is the cylinder that contains a gas which is compressed and kept in the gas cylinder. Actually, that gas, if you release out, it may occupy a large, huge place. If you allow that gas to expand, it may expand an entire colony. That much of gas is there in that. But it is compressed and kept in the cylinder. So what do we have to understand here? A gas can be compressed to a much extent. Next property, a gas expands to a greater extent on being heated. So reverse to that for second point. We can compress a gas at the same time. If you release that, it expands immediately on heating also. So gases can be compressed and expanded in large extent when compared to solids and liquids. Gases freely mix with one another. This is one of the very peculiar property or special property for gases. This is not there for even solids and liquids. This intermixing of gases, this free mixing of gases one another is called as diffusion. This is a special property for the gases, but because of which we are able to feel the smell when you light in some agarbatti in the puja room. Immediately, the fragrance of that agarbatti will be observed or felt by all the people in different rooms. How it is happening? This is being happened by spreading of these fragrance molecules into the gas and spreading into the gas immediately. These gas molecules are intermixing with already existing gas molecules. This mixing is called here diffusion. Because of this property only we are able to observe the smells immediately. So the diffusion is a special property for gases which is not there for liquids and solids. Gases have very large interparticular spaces and negligible interparticle attractions. So here interparticular spaces are very large in case of gases because there are no attraction, there are no boundaries for these gases. They will be randomly moving there and here. There is no friendship at all. So if one molecule is here, one more will be here. Of course, they might be of same gas. So the distance between these molecules will be very high. At the same time, the intermolecular attractions or interparticle attractions are very less. The friendship between the molecules is very less in case of gases. So these are the general properties of gases. So these three we can say general observed physical states of matter: solids, liquids and gases. As we shown in the flow chart earlier, there are two more states of matter. They are fourth and fifth states. Now let us go through those also. Plasma state, the fourth state of matter. Plasma is the fourth state of matter. Plasma is similar to the gaseous state. It seems like a gas, but plasma is made by heating a gas. We know when you heat a solid, it converts into liquid. Generally, it is observed. When you heat a liquid, it starts converting into gaseous form. This is well known for us in the daily life. What happens if you heat a gas? It forms into plasma. It converts into plasma, but it won't be done at normal temperatures. To get a plasma, the gas should be heated to very large extent temperatures. So atoms and molecules in the gas lose all the electrons and form ions and electrons to coexist. That state is called plasma state. This can be obtained by heating the gases to very large extent, to very high temperatures. So we can say the sun and the stars will be glowing. This is because of the existence of plasma in them. So we came to know one thing here, one point here. These sun and the stars are made up of certain gases. Do you know what gas is existing in the sun? Yes, it is hydrogen gas. Hydrogen gas is present in the sun. So this hydrogen gas will be slowly converting into helium form. That reaction we say as a nuclear reaction. About that we are going to learn in the higher classes. But the point here it is, when this hydrogen gas converting into helium form, enormous amount of energy will be released in the form of heat from the gas. Because of that high temperature heat energy, the gases present in the sun and stars, they will be excited. Means they lose all the electrons present in their atoms. There, at that high temperature, ions and free electrons coexist in the phase. That state is called as the plasma state. So now we can say sun is a globe of plasma. Because of the existence of this plasma at this high temperature, only these sun and stars are being glown. They are very bright. So that is about the fourth state of matter. On the earth, as we said, the sun and stars are containing plasma. On the earth also, often we observe this plasma. Plasma is naturally occurring in flames and lightning. When thunder occurs, we observe lightning. This lightning is because of the high voltage electricity passing from clouds to earth. At this high voltage or high temperature, the gases in that place at fractions of seconds will be ionized. Means the electrons present in those atoms of gases will be emitted out. Those free electrons and ions coexist. That state we say as plasma. So in the lightnings also often we can see plasma there, which is bright glowing. And even in northern lights or southern lights also, in the sky often we observe some lightning, some glow from the corners. That glow is because of northern lights or southern lights. And that is also containing plasma in it. So this is naturally occurring on the earth. So mostly plasma is observed in sun and stars. This is about fourth state of matter, plasma. Next, let us say about the fifth state of matter, Bose-Einstein condensate, or generally simply said BEC, Bose-Einstein condensate. In 1924, Albert Einstein and Satyendranath Bose predicted the Bose-Einstein condensate, or BEC, which is referred as the fifth state of matter. We said while discussing about the fourth state of matter, when we heat gas to very high temperature, that converts into ionized ions and electrons to coexist. That we said that phase we said as plasma. To that quite reverse way, if you cool the gas to very low temperatures, very low in the sense to minus degree Celsius, then this Bose-Einstein condensate is appeared or formed. You can see here, this we say BEC or Bose-Einstein condensate. So when a gas is cooled to very low temperatures, this is appeared. A Bose-Einstein condensate is a gaseous superfluid. It is called superfluid. Means the gas cooled to very low temperatures. There, the molecular vibrations are almost freezed. This phase is called BEC. The phase formed by atoms cooled to temperatures very near to absolute zero, means to very low temperatures. A Bose-Einstein condensate is a state of matter of a dilute gas of bosons cooled to temperatures very close to absolute zero. We know absolute zero is nothing but 0 kelvins or minus 273 degrees Celsius. By cooling a gas to that particular temperature, molecules will come to zero vibrations. All the molecules will be tightly binded. The volume of the gas will be almost equal to zero. At that condition, that gas converts into BEC or Bose-Einstein condensate. Under such conditions, at the means when a gas is cooled to this minus 273 degrees Celsius temperature, a large fraction of atoms in the gas, existing in the gas collapse into lowest quantum state. Here the quantum state means the energetic state. Lowest quantum means all the atoms will be having very lowest energy, least energetic atoms will be existing and producing a superfluid which we are calling as Bose-Einstein condensate. So now we have discussed till now about the five states of matter. They are solids, liquids, gases, plasma state, and fifth one, Bose-Einstein condensate or BEC. So this classification of matter is a physical classification, that is nothing but based upon the arrangement of molecules in the matter. We have discussed about the general properties of this matter also. In out of these five states, three are generally occurring solids, liquids, and gases. The remaining two are a little different from the remaining special conditions. Now, based upon these states of matter, we are going to see some questions here. Out of them, the first one, read the question carefully. A few substances are arranged in the increasing order of forces of attraction between their particles. Which one of the following represents a correct arrangement? Now let us see options what they are given. First one, water, air and wind. Second one, air, sugar and oil. Third, oxygen, water and sugar. Fourth one, salt, juice and air. So they are asking to find out, first we have to know what are the force of attractions, and then the increasing order of force of attractions we have to identify from these all. If you observe the forces of attraction, while we were discussing about the general properties of the solids, liquids and gases, we told the attraction existing between the molecules of matter are called forces of attractions. So these forces of attractions are much high in solids, and these are very low in case of gases, and they are moderate in case of liquids. Now if you observe in the first option, water is a liquid, whereas air is a gas, wind is also a gas. So liquids are having greater attractions than these gases. So it is not the increasing order. Next one, first it is given air, a gas which is having a lower force of attractions, correct only. Next one, solid, sugar is given which is a solid. In this very much high force of attractions are there. So it is in the increasing order only till here. But by coming to oil, oil is a liquid. In this case, the force of attractions are higher than the air, but less than that of in sugar. So this is not the correct increasing order. It is increasing from air to sugar, but again decreasing to oil. So they are asking to find out increasing order. So it is not the correct answer. Next, if you observe the third option, first it is given oxygen, which is a gas, which is having lower force of attractions. And next, if you observe water, which is a liquid, there some force of attractions are somewhat greater than in the case of oxygen. So increasing order till here. Next, sugar. Sugar is a solid which is having highest force of attractions when compared to these two. So this is in the increasing order. Oxygen has a less force of attraction than water. Water has less force of attraction than sugar. So here we can identify, we can understand these three are in the increasing order of their force of attractions or force of attraction between the particles. So now C is the correct option. What about the fourth option given here? Let us say about it also. First one is salt. It is a solid. The force of attractions are much higher in this case. Next one, juice, which is a liquid. So from salt to juice, it decreases. Order decreases. So from here itself, we can say it is wrong because they are asking increasing order. So the correct option only C. In that only they have given first gas and then liquid and at last solid. So the force of attractions are increasing from oxygen to sugar. The same might be asked another way. Write the decreasing order of intermolecular spaces. For that also C will be correct answer because intermolecular force of attractions will be intermolecular distances are quite opposite to intermolecular force of attractions. If attraction increases, distance decreases between the molecules. If attraction decreases, molecules move away so that distances increases between the molecules. Now let us see next question. Read the question here. The property to flow is unique to fluids. As we said in the discussion, the substances which can move in their own are called fluids. Which one of the following such statements is correct about these fluids they're asking? Let us see the statements first. First one, only gases behave like fluids. Is it? Second one, gases and solids behave like fluids. Third option, gases and liquids behave like fluids. Fourth option given, only liquids are fluids. So what are fluids? First we have to remember once again. We have to revise once again. Recollect the points about fluids. We said the state of matter which can flow in its own is called a fluid. To be flown, the attractions, the interparticular attractions between the molecules should be less. So the particles or the matter which are having less interparticular attractions can slide its molecules one another so that they can flow. So in which state of matter interparticular force of attractions are less? As we know, out of these three states, solids are having high interparticular attractions. So it cannot move its molecules. They are tightly binded. So solids are not fluids. Liquids, in liquids, molecules are loosely packed. There are some attractions, but less when compared to solids. So here, because of less attractions, the molecules can slide one another. So liquids can flow, but it is only in one direction. That is from higher altitudes to lower altitudes. Anyhow, they are flowing, so they are fluids. Liquids are fluids. Next, gases. By coming to gases, molecules of gases can move in any direction. So a gas can flow very easily from one direction to another. The main difference between the liquids and gases is gases can flow in any direction. There is no boundary for them. All the available space will be occupied by them immediately. But gases or liquids can flow only in one direction, that is from higher altitudes to lower altitudes. So here we understood liquids and gases are fluids, whereas solids are not fluids. Now let us go through the options once again. Only gases behave like fluids. Is it correct? No. Gases, not only gases. If you see second one, gases and solids behave like fluids. But here, gases are fluids only but not solids. So this is not correct. If you see third one, gases and liquids behave like fluids. Means these two can flow from one place to another place because of loose packing of molecules in them. So C is correct answer for this. Fourth one, what they have given? Only liquids or fluids. No, it is also not correct because gases also can. So let us say one more question. In which state are the distances between the particles are greatest? Options, let us say gaseous state, liquid state, solid state, both liquid and solid states. The distances between the particles greatest. So the state of matter in which the particle distance is greater. As you know, in solids, molecules or particles are tightly binded. There are no spaces between them. Means the distance between the adjacent particles is very less. So the interparticle distance is very less in case of solids. But they are asking to find out the greatest. The quite opposite that is in case of gases. In gases, molecules are very loosely packed, no attractions, they can move in any direction freely, they have much freedom. So the distance between the molecules will be very great or very much high or greatest in case of gases. So now the correct option for this will be A, or gas. Next, let us go through fourth question. Which one of the following is a property of gases? Let us see options. They have no rigidity. They can diffuse, they have definite mass, all of these. Let us see what are the options or properties given here about the gases. First one, rigidity. Rigidity means uncompressibility, not able to change its shape by a compressing or applying pressure on it. Is it true about gases? No. Gases are not rigid. They can be easily changed. We can change the shape of the gas very easily. They can be compressed very easily by applying pressure. The compressibility of gases is very much high when compared to liquids and solids. So gases are no more rigid. Gases have no rigidity. They can be easily compressed. So first option is correct regarding gases. Second one, they can diffuse. I said already, diffusion means spreading or intermixing of gases. Intermixing of particles of different matter one into other easily is called interdiffusion. Because of this diffusion property of gases only, we are able to observe the smells. Very fine example, if you spray certain perfume in a room at the corner, the fragrance of that perfume can be observed or felt by the people in the home entirely from all the rooms immediately also. This is because of these fragrance molecules are spreading in the air along with other molecules very rapidly. This spreading property of gases is called diffusion. So this is one of the properties of gases. So B is also correct about gases. Next one, they have definite mass. Yes, this is one of the important point to be discussed about mass of matter. Whatever the state of matter, all the matter have fixed mass for it. We said some properties are varying from solids to gases. If you say shape, solids have fixed shape, liquids have no fixed shape. They take the shape of container. Even gases also having no fixed shape, they take the shape of container. By coming to volume, solids have fixed volume, liquids also have fixed volume, but gases, they do not have fixed volume. They occupy the volume of container in which they kept. But by coming to mass, it is the only property which is being commonly same for all. They have fixed mass. Whatever the matter you take, if you observe the mass, it will be always fixed for it. They have that we say matter has definite mass. It might be a solid or a gas. So this is applicable for gases also. So these three are the correct properties of gases. Now the correct option will be here. Fourth one, that is all of these. Next, let us one more question. Certain substances exist in the solid state because why? Some substances are exist in the solid state. They have given some reasons. Let us see one by one. Intermolecular force of attractions are weak, so they exist in the solid state. Molecules can slide one another, so they exist in solid state. Molecules are tightly packed, so they are in solid state. Molecular motion is very fast. So which is the correct option for the statement given here? Some substances are in the solid state. What is the reason for being in the solid state? What will be the correct answer? Yes, if you select C, you are correct. Your correct answer is correct here because molecules are tightly packed. Because of that, they won't move from one to other. They'll be always having fixed shape and fixed volume. Hence, they are solids because molecules are tightly packed in them. So here, C will be correct answer for this question. Let's see one more question here. They have given certain liquids taken in the container. Let us read the question once. A student poured an equal amount of water into 4 containers as shown below. What result does this experiment show? Say they have given certain quantity of certain quantity of liquid in different shapes container. So they're asking to find what results does this experiment show. Let us see options. Water has definite volume, water has no definite shape, water has definite mass, water has no definite volume. So from this experiment we can identify that water or any liquid occupying a fixed volume, but here based upon this experiment shown here, we can say clearly water has no definite shape. It is taking the shape of the container in which it is kept. See here, first it is taken flask shape, next beaker shape, test tube shape, and next the funnel shape, sorry, beaker shape there, container shape. So here correct option regarding this question will be B. So this is about different states of matter. Hope you understood about the 5 states of matter. Thank you for watching our video. Please subscribe our channel so that we will be getting all updates regarding our live classes. We will be getting directly into your YouTube. You will get updates regarding our classes, live classes, what we are going to help, what we are going to help in this. So you can easily log into them to watch these live classes and press the bell icon to receive these latest updates about all. Thank you.